All right, I've had a question about number 5 in lesson 10. So the question asks, where does the line that's given there, line R, meet the XY plane, the XZ plane, YZ plane? So I'm just going to do part A for you, and then from there, you should be able to do the other two parts. So the first thing we need is the equation of the XY plane. So for our XY plane, we know we have two direction vectors. So on the x-axis, our direction vector would be 1, 0, 0. It's pointing down the x-axis. Your second direction vector would be on the y-plane, so 0, 1, 0. Then you go ahead and you do the cross product, but we know that the normal is going to be perpendicular to the xy plane, and I already know that it will be heading down the z-axis. So there's really no calculations when you're working with the xy plane, xz plane, so on and so forth. So that would tell me that if I go through, and I'll do the entire process here. So your reference point minus the point on the plane, dot your normal, equals 0. Well, my coordinate here, it's on the xy plane, so that means 0, 0 is going to be a coordinate. So when we go through and do the calculation, technically we would have x minus 0, y minus 0, z minus 0. Kind of doing a ton of steps here just to show where things are coming from though. And your normal would be 0, 0, 1. That's equal to 0. So when you go ahead and do that calculation, distributive law, we find that, or do the dot product, that those go to 0. So we end up with z equals 0. So that is the equation of the scalar equation of the xy plane. Second part then is to go ahead and determine where does that line intersect. So I'm going to group that together to give myself a little bit more room. So moving over here, process is substitution. So I'll just rewrite that line in parametric format. Again, it's going the extra distance series. Most of you will be able to pick that off without going through all the steps. T z equals 1 minus t. And if the equation of the plane is, z equals 0. So there's my plane. Now I do my substitution. There's only one substitution to do, and that is the z value. So 1 minus t equals 0. And B and C are going to be equally simple because those equations for the planes are very, very similar to that. So we end up with t equals 1. So that is the scalar value. Scalar value when the line crosses the xy plane. Now it wants us to find the actual value or the coordinate. So that means I'm going to go back to my equation and do the substitution. So 6 plus 3 times 1. So I'm replacing all my t's with 1's. Z equals 1 minus 1. So therefore my coordinate will be located at 9, 14, and 0. All right, so there's your process to do this question. You need to find the equation of the plane first. Then you need to do your substitution, and that will result in finding the scalar value, which then you can substitute back in and find your point. If you have any questions, let me know.